Okay, alright. So now we're going to go into the last subtopic for chapter 2, which is electronic configuration. Alright, so the learning objectives for today, we will learn how to explain what is Aufbau principle, Hans rule, Pauli's exclusion principle. These are the rules for you to know how to write electronic configuration. And then you're going to predict the electronic configuration of atoms and monoatomic ions using SPDF notation. And then justify the anomalous electronic configurations of chromium, Cr, and copper, Cu. Okay. Another two things that you will learn is actually like refresh is writing your electronic configuration in the SPDF notation and your orbital diagram. I think you learned this in SVM, so it will be like a refresh je lah. So electronic configuration, what is it? It is an electronic configuration is something that describes the arrangement of electrons in an atom. So it will show how your electrons are filled in the orbitals of your atom. Okay, so let's say if we have fluorine atom with 9 protons. So since it is an atom, therefore it will have 9 electrons as well. So how will we write the orbital diagram for fluorine with 9 electrons? We will fill in the 1s orbital with 2 electrons first, 1, 2, and then 2s, 3, 4, and then 2p, 5, 6, 7, 8, 9. Okay, so that's how you fill in your orbital diagram, and you have to make sure when you draw your orbital diagram, okay, you only put the subshell, okay, 1s, 2s, and 2p. Okay, so you cannot write 1s2, 2s2, 2p 5. That will be wrong. Okay, you have to make sure that it is just your orbitals. Okay, so you must also know that one orbital can occupy up to 2 electrons. Okay, so that is your orbital diagram, and make sure that your electron is represented by double-headed arrows. Okay, so the different spins, spin up means that it is the plus half, maksudnya clockwise. The spin down will be minus half anti-clockwise. Alright, so next we are going to write the SPDF notation for your fluorine atom. So since it has 9 electrons, so basically you are just bringing down the number of electrons from the orbital diagram. So you will write 1s2, since it has 2 electrons, 2s2, and 2p 5. Okay, so that's how you write the SPDF notation. Simple. Okay, so next we're going to do this example where your question asks you to draw orbital diagram and write SPDF notation. So the keywords when you are told to show the electronic configuration is, if they ask you to draw, it means you have to give orbital diagram. If they ask you to write the electronic configuration, then you must give in SPDF notation. Okay, so that is like a tip for you in exams. Okay, so since it asks for oxygen atom, that means you know that oxygen has 8 protons. Since it's an atom, that means you have 8 electrons. Okay, so let's fill in your electrons in the orbital diagram, so you have to draw nicely your orbital diagram first. Okay, 1s, 2s, 2p, and then you will fill in your electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is your orbital diagram, and your SPDF notation. I already write it siap-siap. But is there anything wrong with... Okay, nothing wrong. Okay, nothing wrong. So now, if you notice up here, this is something that we learned from 2.2. Okay, your quantum numbers. So I want to show you how to translate, bukan translate lah, kira macam relate your quantum numbers with your electronic configuration. Okay, so magnetic quantum number M is your orientation of your orbitals. So that will be your kotak. Okay, so this will be this, okay, so like you know that for p orbital you have 3 values of m, kan? So that means you have 3 orientations of the orbitals, of p orbitals. So here you have 1, 2, 3 boxes which shows the 3 orientations of your 2p orbitals. Okay, px, py, pz. Alright, so same goes for the one on the right. Okay, your magnetic quantum number will actually be 2px, 2py, and 2pz lah. Dia punya it is translated to that. Okay, so next we have the principal quantum number. Principal quantum number will be your N, your energy level, your shell. So which one will that be? I'm gonna use blue color. Okay, this one will be your 1, 2, and 2. Okay, so that is your principal quantum number. Alright, okay, another thing that you have is your angular momentum quantum number, which is L, which gives the shape of your orbital. So which one will that be in your electronic configuration? Let's change color to orange to represent L. That is your S, and P orbitals. Okay, so this one tells you that this is L equals to 0, L equals to 0, L equals to 1. Okay, so basically, let's say let's change color lagi. For this electron here, okay, the quantum number, the set of quantum number will be N, L, M, S equal to, the N will be 2, L will be 1 because it is p orbital, M will be anything. Let's say I will put -1, and your S can be, since it's up, I will put +½ So that is the possible set of quantum number for that electron. Or it could be 2, 1, 0, okay, -1/2 pun boleh. Okay, right, so that is the relation between your quantum number and your orbital diagram lah. So for SPDF notation pula, okay, principal quantum number, you already know it is the N, okay. Your azimuthal quantum number or angular momentum quantum number, L, which shows the shape, will be your alphabet here, okay. And then the numbers up here, let's see what color should I use, green, 2, 2 and 4, that tells you the number of electrons in the subshells, okay. So in subshell 1s you have 2 electrons, in subshell 2s you have 2 electrons, okay. You can see here it is the same. In subshell 2p you have 4 electrons altogether. Alright, so that's the relation between these two and your quantum numbers. Right, so there are principles and rules that you have to obey and follow in order to write your electronic configuration. They are your Aufbau principle, Pauli exclusion principle, and Hans rule. So let's go to Aufbau principle first. So these are actually simple rules, okay. Aufbau principle states that the electrons are filled in the orbitals, okay, in order of increasing energy. What does that mean? It means that electrons should occupy the orbital with the lowest energy orbital first before occupying the one with higher energy. So kita akan fill in electrons, okay. Kalau tengok on your right here, the relative energy of atomic orbitals have the energy. You will fill in electrons starting from the lower energy orbital, which is 1s. So you will fill 1, 2 electrons here, followed by 2s, and then 2p. So there will be 6 electrons here, and then 3s, and then 3p, okay, and 4s, 3d, and so on, okay. So notice here that it starts with 1s, 2s, 2p, 3s, 3p, 4s, 3d, okay. 4s first before 3d because 4s orbital has a lower energy, than 3d orbital, okay. So this is the sequence of your orbital energy, okay. So how to remember? You can write down this way. You write 1s and then followed by 2s, 3s, 4s, 5s, 6s, 7s, and then get the p, 2p, 3p, 4p, 5p, 6p, 7p, then 3d, 4d, 5d, 6d, 4f, 5f, okay. And then you draw arrow cutting from up here, the lowest energy orbital, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on, okay. So this is the sequence, okay, for you to fill in your electrons from your lowest energy orbital, ascending to the higher energy orbitals, okay. So in this case, this means that 1s has the lowest energy, 1s orbital is the lowest in energy, and 7p orbital is the highest in energy, okay. So this is the order of filling your orbitals with electrons. So it starts with 1s being the lowest, okay, and sampai 5s the highest, right? So let's say if we have a beryllium with 4 protons, since it's an atom, so it has 4 electrons as well. So the electronic configuration, okay, for beryllium will start with 1s and then 2s, 2p, 3s. So since we are going to fill in 4 electrons only, it is 1s, 2s. So 1s2, fill in with 2 electrons, and then the next 2 in 2s. Okay, so basically follow lah the energy. 1s dulu baru 2s. Okay. Okay. Next rule is the Pauli exclusion principle. So the Pauli exclusion principle mentions that no two electrons in an atom can have the same 4 quantum numbers and LMS. Okay, so what does this mean? It means that, okay, let's say we have helium with 2 protons. So since it's an atom, it will have 2 electrons. So I'm going to fill in my electrons. Okay, I will fill in this way. 1 spin up, 1 spin down. Okay, why do I do that? Because, okay, my set of quantum numbers for this electron and this electron must be different. Okay, they have at least they must have unique NLMS set of quantum numbers. So your NLMS and LMS for the left electron will be basket. It will be 0. 1, 0. M is 0 since L is 0, and plus half. While the one on the left will have N, L, M, S equal to 1, 0, 0. Itu sama, but it is spin down, which is minus 1 over 2. Okay, so this means that I am obeying the Pauli exclusion principle, where my electrons, both these electrons in the in this helium atom has unique set of quantum numbers. It cannot have the same 4 quantum numbers. Let's say if I did like this kan, that means that this one here, my spin will be plus half as well. So this will be wrong. I am not following Pauli exclusion principle. Okay, so it has to be spin up, spin down within one subshell. Okay, within one box, within one orbital, one s orbital. Okay, so let's say, okay, when you have NP2, apa-apalah kan NP2, how will you fill in your electrons? Is it A, B, or C? Which one shows you obeying the Pauli exclusion principle? It will be this one. Okay, oh, this one actually bukannya Pauli exclusion principle je, also Hans rule. Okay, so it will be A, because you want to obey both these rules. Okay, this one is wrong because you have to obey Hans rule. This one is wrong because you are not obeying Hans rule as well. Okay, tiba explain yang ni. So next rule is Hans rule. So what does Hans rule say? It states that, okay, before that, okay, for Pauli exclusion principle, I want to tekankan that if you have 5 electrons in an atom, okay, you will have 5 sets of quantum number that are unique. So maksudnya bila ada 5 electrons dalam satu atom, kelima-lima elektron tu ada NLMS yang berbeza. Okay, berbeza. Okay. Alright, moving on to Hans' rule. Hans' rule states that when electrons are added to the orbital of equivalent energy, so these equivalent energy orbitals are called degenerate orbitals, like p orbitals. Okay, you will have px, py, pz. Okay, atau kalau d orbitals, you will have dxy, dxz, dx, dyz, dx square, y square, dz square. So these orbitals have the same energy. Okay, so they are called degenerate orbitals. So when you are filling electrons in these degenerate orbitals, each orbital are filled singly with electron of the same spin before it is paired. Okay, so this one is about stability. Alright, you will fill in singly first before you pair your electron. Okay, contohnya macam awak masuk bus. Okay, masuk bus kan, the seats are like 2, 2, 2 atau 3, 3, 3 kan. So bila awak masuk bus, awak mestilah akan duduk seat yang kosong, sorang kan. Kalau dengan stranger, awak tak nak duduk sebelah orang, betul tak kan? So macam tu lah elektron awak, dia tak nak duduk sebelah-sebelah dengan, dia tak nak pair. Okay, dia tak nak pair, duduk singly dulu. So let's try to fill in the electrons for nitrogen and oxygen first. So your nitrogen atom has 7 electrons. So 1, 2. So start dengan lowest energy orbital 1s, 3, 4. Okay. Then bila awak sampai kat 2p, which are degenerate orbitals, okay, the same energy, you will fill in singly first. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, macam tu. So kalau oksigen pula ada 8 elektron. Okay, yang ni tak ada masalah. Okay, and then 1, 2, 3. Okay, singly first, and then you pair it up. Alright, so that is what is meant by Hans' rule. Okay, so contohnya kalau dia dalam energy diagram ni, okay, you have 1s, 2s. Okay, pasal awak punya 2p, it is of the same energy. Tengok same energy. Okay, same energy. Same energy. So when you fill in, okay, you will fill in, let's say for oxygen lah, oxygen 1, 2, 3, 4, and then bila sampai degenerate orbital ni, degenerate orbital, okay, 1, 2, 3, okay, singly first, and then 4, baru you pair. Okay, that's what is meant by Hans' rule. Alright, so you have to pay attention with the way I fill in my electrons. Okay, sorry, yang ni saya buat slow-slow tu supaya awak boleh nampak. So yang ni I think you can try on your own. Ingat ditulis SPDF notation. Okay.